Hi, my name is Nurafrina Farzana from Sanyo. This is my lab reflection video for job sheet 6, where we study the differences analysis between delta star and star delta connection, balanced and unbalanced three-phase. In this lab, we explore two main types of three-phase connection, which is the delta star and star delta. We didn't use actual hardware. Instead, we use MATLAB and Simulink to simulate the circuit. Though this was great because we could easily change values and see how it affects the result. Here's a quick rundown on what we did in MATLAB. We set up simulation models for both delta star and star delta configuration. You can see the simulating block diagrams in my report. We look at both balanced and unbalanced load condition. We measured things like line currents, phase current, line voltages, and phase voltages. The cool thing was that we could see how changing the load resistance affected the currents and voltages in real time within the simulation. Okay, so let's dive into the differences between delta star and star delta. In a delta star connection, the source is connected in the delta configuration and the load is in a star configuration. One key thing we observe is the relationship between line and phase value. From my result, we can see that the line voltage is square root of 3 times the phase voltage. The line current is equal to the phase current. In a star delta connection, it's the opposite. The source is in a star and the load is in delta. Here, the line voltage is equal to the phase voltage, but the line current is square root of 3 times the phase current. These relationships are super important for calculating power and understanding how the connection affect the overall system. We also look at balanced and unbalanced load, which was another key part of the lab. A balanced load is when all three phases have the same impedance. In our simulation, this meant all the resistors were equal. When the load is balanced, the calculations are much simpler, and the neutral current in star connection is zero. We saw that the power was equally distributed across the three phases. This is where the impedances are not equal. In our simulation, we changed the resistance of one of the loads. We saw that the currents and voltages in each phase were different. Also, in a star connection, an unbalanced load results in a non-zero neutral currents. Looking back at my lab result, I can see the concept in action. For example, in the delta star balanced load setup, the voltage and current values match the relationship we discussed. And when we made the load unbalanced, the simulation clearly showed the differences in phase current and voltages. The tables in my report shows the specific values. It was really helpful to see how the formula we learned in class actually apply in a simulated circuit. The MATLAB simulation made it easy to compare the theoretical calculation with the measured values. Overall, this lab was a great learning experience. It helped me to visualize and understand the differences between delta star and star delta connection and the impact of balanced and unbalanced load. One of the challenges I faced was making sure I correctly interpreted the MATLAB output.